going to discuss about geometric progression. In the previous class we have completed arithmetic progression. Now we are going to discuss geometric progression. It is also known as GP. Let us take the definition of geometric progression. A set of numbers which are arranged such that every term is obtained by multiplying the preceding term by a fixed number is called a geometric progression or GP, and that fixed number is called common ratio. Let us see some example. In the numbers 2, 6, 18, 20, 54 and so on, first number is 2. It is multiplied by 3 to get the next number 6. Again 6 is multiplied by 3 to get the next number 18. Again 18 into 3 is 54. It continues like this. So this kind of progression is called geometric progression, and ratio of any two consecutive terms will be a constant. Okay, and that constant ratio is called common ratio. Alright, the next point, if we take the first term of a geometric progression as A and the common ratio as R, then the GP will be A first term into R, AR is the second term, next term is AR square, next term is AR cube and so on. Alright. Now by observing these terms you can tell the formula for the nth term of the GP. Nth term of the GP is denoted by Tn. What is the formula? If you observe, in the second term the power of R is 1, in the third term the power of R is 2, in the fourth term 3, in the first term 0. So what will be the power of the nth term? It will be A R power n minus 1. Alright. So the formula for nth term of a GP is A R power n minus 1. Now the sum up to n terms, for any progression the sum up to n terms is denoted by Sn. So Sn is equal to A into R power n minus 1 by R minus 1 when mod R is greater than 1, and A into 1 minus R power n by 1 minus R when mod R is less than 1. You can notice that both are value wise same. Just we have reversed the numerator and denominator only to avoid negative numbers, but otherwise formula is same. So how to derive this formula I will explain briefly. Let us write the series A plus AR plus AR square plus AR cube and so on. What is the nth term? Last term AR power n minus 1. Alright, and the sum is denoted by Sn. Now to calculate the sum we multiply both sides by common ratio. What is the common ratio? R. So multiplying both sides by R, you will get R into Sn is equal to, after multiplying by R, write the second term starting from the second place. A into R will be AR, write it under the second term. Next AR into R will be AR square, write under the third term. Next AR square into R, AR cube. Next this into R, AR power 4 and so on. What is the preceding term to AR power n minus 1? It will be AR power n minus 2. If you multiply by R, you will get AR power n minus 1 plus, when this is multiplied by R, you will get AR power n, that comes here. Alright. Now you might have understood why we have written the second row starting from the second place, because we are getting the common terms. We are going to subtract the two. We are going to subtract the two sequences. This minus this is 1 minus R into Sn. alright, is equal to, when you subtract A minus, there is nothing, so it is A plus AR minus AR cancel, AR square also cancels, AR cube cancels, AR power 4 cancels, this and this will cancel. And after this last term in the first row there is nothing, so just take it as 0, 0 minus AR power n will be yeah. Now you will get 0 minus AR power n will be minus AR power n, and that is A into 1 minus R power n. Alright. Now what is Sn? Sn will be A into 1 minus R power n upon 1 minus R, dividing on both sides by 1 minus R. So this is how we get the formula. And we write the same as R power A into R power n minus 1 by R minus 1 when mod R is greater than 1, and as it is when mod R is less than 1. But what if mod R is equal to 1? If mod R is equal to 1, then R will be plus R minus 1. Then what will be Sn? If you take R is equal to 1, you will get A plus A plus A plus and so on, A plus A plus A plus and so on n times. The sum will be NA. If R is equal to, this is if R is equal to 1, and if R is equal to minus 1, then you will get A minus A plus A minus A and so on. A minus A plus A minus A and so on. So it depends on the value of n. If n is even, then all the plus A's and minus A's will cancel out. The answer will be 0. If n is even. If n is odd, then after cancelling plus A's and minus A's, 1 plus A will be remaining. So the sum will be plus A if n is odd. Alright. But usually we don't consider these cases. When 3 numbers are said to be in GP, then we assume that common ratio is not equal to 1, mod R is not equal to 1. If R is equal to 1, what happens? All numbers are equal to each other, then the series can be called as AP or GP. So if some numbers are in AP and GP, if some numbers are in AP as well as GP, then all numbers are equal. You have to remember this point. Alright. Now, next point, properties of GP. If A, B, C are in GP, then what is the property of GP? Ratio must be same for any two consecutive terms. So ratio of A and B is B by A. It should be equal to ratio of B and C, that is C by B. So B by A is equal to C by B, or you can remember it as B square is equal to AC, cross multiplication. B into B, B square is equal to A into C, AC, or B is equal to plus R minus root AC. Okay. Now, if T1, T2, T3 and so on Tn are in GP, then same property, T2 by T1 is equal to T3 by T2 is equal to T4 by T3 is equal to and so on Tn by Tn minus 1. And also a very important property is here. What is that? Product of first term and last term will be equal to product of the second from left and second from right is equal to product of the third from left and third from right. That is T1 into Tn is equal to T2 into Tn minus 1 is equal to T3 into third from right, Tn minus 2 and so on. In AP, what we have discussed, if T1, T2, T3 and so on Tn are in AP, the sum of the terms equidistant from left and right will be same. The same thing here in GP is product of the terms equidistant from left and right will be same. Okay. Let us proceed to the next point. If A, B, C are in GP and suppose k is some number not equal to 1, k is a non-zero number, then by adding the fixed number k to every term of the GP, A plus k, B plus k, C plus k will not be in GP. Similarly, A minus k, B minus k, C minus k are not in GP. In case of AP, what we have discussed, by adding a constant or subtracting a constant to every term, the resulting series will be again AP, but in GP it is not, right. Now, multiplying every number by k, Ka, Kb, Kc are in GP, because the ratio remains same. Here B by A is equal to C by B. Here if you divide second term by first term, you are getting B by A. If you divide third term by second term, you are getting C by B. Both are equal. Common ratio is also same. Similarly, if you divide every number by a fixed number k, A by k, B by k, C by k are in GP. Okay. These are the properties of GP. And one more point, infinite GP. In case of AP, you cannot find the sum up to infinity, but in case of GP it is possible under certain restrictions. If mod r is less than 1, then A plus AR square and so on up to infinity is equal to A by 1 minus r. This is called infinite GP. But why is mod r less than 1? Let us discuss. You take sum of n terms of a GP, A plus AR square plus and so on, A r power n minus 1. What is the formula for the sum? If mod r is greater than 1, we have discussed the formula like this. Now, if n is approaching infinity, then we denote the sum by S infinity. Now, what is the value of r power infinity? R power infinity, if you take, when mod r is greater than 1, for example, I will take r is equal to 3, then 3 power infinity means 3 into 3 into 3 into 3 into and so on infinity times. Every time when you multiply by 3, it is becoming 3 times. So, it is becoming 3 times continuously and indefinitely. So, what happens to the final number? It will be approaching a large number which you cannot tell. So, that is called infinity. So, whenever the base is greater than 1, the number will be keeping on increasing. Okay. So, finally, it tends to infinity. We have to write 3 power infinity tends to infinity, approaches to infinity. Similarly, if you take another example, say 5 by 2 whole power infinity, it also tends to infinity because the base is greater than 1, it keeps on increasing. But when the base is less than 1, for example 1 by 2 whole power infinity, what happens? 1 by 2 into 1 by 2, it becomes half. Again 1 by multiply by 1 by 2, it becomes again half. Then if you continue it till infinity, what happens? That number is becoming half every time. If you continuously do it till infinity, finally nothing will be left. But it cannot become 0. So 1 by 2 whole power infinity tends to 0. but its actual value will never become 0. Okay. So, we have to remember that when the base is less than 1, that number power infinity tends to 0. When the base is greater than 1, that number power infinity tends to infinity. Even if it is negative. Okay. If it is negative, what happens? If the power is even, it becomes plus infinity. If the power is odd, it becomes minus infinity. Is it not? And here also, even if it is negative sign, then you will get, you can separate that negative sign and write minus 1 whole power infinity into 1 by 2 power infinity. 1 by 2 whole power infinity tends to 0. This may be plus 1 or minus 1, but the final product will be tending to 0. So, in this case, when mod r is greater than 1, what is happening? This is becoming infinity. So, infinity minus 1 is infinity. Infinity into any finite number like this will be infinity. So, the sum will be approaching infinite number. You cannot determine the sum. That is why we are taking only mod r less than 1. When mod r is less than 1, we write the same formula as a into 1 minus r power n upon 1 minus r. And when mod r is less than 1, this r power n is r power infinity tends to 0. So, this is 0. Then what is the remaining? A into 1 minus 0 by 1 minus r, it will be a by 1 minus r. Okay. So, when mod r is less than 1, then the sum of this infinite GP is a by 1 minus r. But sometimes this condition won't be given. But in the question, if he says that a plus ar square and so on is infinite GP, then automatically this condition will be implied. Okay, even if it is not given, we have to take that condition. Alright. For example, 2 plus 2 into minus 1 by 3 plus 2 into minus 1 by 3 whole square plus 2 into minus 1 by 3 whole cube and so on till infinity. Clearly it is a GP with common ratio minus 1 by 3. So, the sum of this series is equal to a by 1 minus r. A is 2. 2 by 1 minus of common ratio minus 1 by 3, that is 2 by 1 plus 1 by 3 is 4 by 3. Then if you simplify, you will get 3 by 2. But remember that this sum of this infinite GP will never become equal to 1 by 2. It will be approaching 1 by 2. Actually, we have to write tends to 1 by 3 by 2. But even if you write equal to, that is ignored. Okay. So, this is about infinite GP and its sum. Alright. Now, let us solve some problems on GP today. Problem number 1. The product of 3 numbers in GP is 216 and the sum of their products taken in pairs is 156. Find the numbers. In AP, we have discussed a few points. In any question, if 3 numbers are said to be in arithmetic progression, then instead of taking the numbers as a plus d, a plus 2d, we take a minus d, a plus d, only for the sake of calculation simplification. Similarly, in GP also, when 3 numbers are in GP, instead of taking ar square, first 3 terms of a GP are usually taken as ar square, but sometimes we take a by r, ar. These 3 are also in GP, but first term is a by r, common ratio is r. Why? Because while calculating the product, r's will cancel, we will be getting only a. That will be easy and comfortable for the calculation. So, let the numbers be a by r, ar. If there are 4 numbers, how do you take a by r cube? For 4 numbers we have to take a by r cube, a by r, ar, ar cube, so that the product becomes independent of r. Okay. Suppose there is no calculation involving the product of the 4 numbers or product of the 3 numbers, then no need to take like this. You can take here a ar, ar square, there a ar, ar square, ar cube. Alright. Okay. Now, if we take the numbers as a by r, a, ar, let us apply the conditions. The product of the numbers is 216. What is this product? If you multiply, r will cancel out, you will get a into a into a cube is equal to how much? 216. Alright. Can you write 216 as a cube of something? Yes, you can write 216 as 6 cube. Alright. So, write this as 6 cube. Then cancelling cubes, you will get a is equal to 6. So, we already got the middle term. Now, sum of their products taken in pairs is 156. What is the sum of the products taken in pairs? 3 numbers are there, take a pair. Pair means 2 numbers, any 2, multiply. Like that, how many pairs will be there? This into this 1 pair, this and this 1 pair, this and this 1 pair, 3 pairs. Sum of those products of the 3 pairs is equal to 156. So, let us write it, this into this, a by r into a plus this into this, a into r plus this into this, r will cancel out, I will write a square, is 156. Now, we already got the value of a, so substitute a square 36 by r. Next, plus here a square into r, 36r plus a square 36 is equal to 156. Alright. Now, 36 will cancel. Here you can take 36 common, 1 by r plus r is equal to 120. 156 minus 36, 120. So, 1 by r plus r will be 120 by 36. So, you can cancel the common factor. Alright. So, what is the common factor? Twelve tens and 12 threes, 10 by 3. Now, cross multiplying, this is 1 plus r square by r is equal to 10 by 3. Cross multiplying, we get 3 plus 3 r square equal to 10 r. Alright. Now, 3 r square minus 10 r plus 3 equal to 0. You know how to factorize it? The factors will be 3r minus 1 into r minus 3 is equal to 0. We will get 2 values of r. R is equal to 1 by 3 r3. Already we got a is equal to 6. So, the numbers are, if r is equal to 1 by 3, the numbers are what are the numbers we assumed? A by r, a r. A is 6, 6, r is 1 by 3. 6 by 1 by 3 is what? 18. 18 comma a is 6 and next is ar. A is 6, r is 1 by 3. So, it will be 2. Now, the second case, if r is equal to 3, Then first A by R means 6 by 3, that is 2, A is 6, AR will be 18. We are getting the same numbers, but in the backward order, in the reverse order, but we have to consider this and this as two separate GPs, alright. So this is the first question. Now we are going to solve the second question, alright. Find the 3-digit number such that the digits are in GP and the digits of the number obtained from it by subtracting 400 are in a form AP. There is a 3-digit number, its digits are in GP. On subtracting 400, you will get another 3-digit number and those digits are in AP. That is the given question. Then we have to find the 3-digit number. Suppose the digits from left to right in the 3-digit number are X, Y, Z. Z is in units place, Y is in tens place, X is in hundreds place. Then X, Y, Z are in GP. Alright. Then if this is the 3-digit number, what is the actual value of the 3-digit number? Since X is in hundreds place, X contributes the value 100X to the number. Since Y is in tens place, then Y contributes the value 10Y to the number plus 10Y. Z is in units place, it contributes the value Z. So this is the value of the 3-digit number when the digits from left to right are X, Y, Z. Alright. But since it is given that the digits are in GP, let us assume that the digits X, Y, Z as A, AR, AR square. Let the digits be A, AR, AR square. They are digits of the 3-digit number. So digit means it varies from 0 to 9. Okay, either 0, 1, 2, 3, it is an integer, it can be 0 or maximum 9. But the hundreds place cannot be filled with 0. So here A should lie between 1 and 9 and A must be a positive integer. Of course, AR and AR square may be 0, but if AR is 0, what happens? R should be 0. Then you are getting 0, 0. Then the numbers won't be in GP. So that's why here R should be AR also lies between 1 and 9. One is less than or equal to AR and even AR square less than or equal to 9. So A is an positive integer between 1 and 9 and AR is a positive integer between 1 and 9, AR square also. Okay. Now let us proceed. What is the value of this number now? A is in hundreds place, so it is 100A plus AR is in tens place, so 10 AR plus units place AR square. This is the value of the number. Now when we subtract 400 from this number, we will get another 3-digit number whose digits are in AP. So now let us subtract 400. Subtracting 400. When we subtract 400 from a 3-digit number, what happens? On subtracting, z remains as it is, z minus 0, 0, y minus 0, y. So, this will be, this first digit becomes x minus 4, isn't it? So, on subtracting 400, how do you write that number? 100a minus 400, that will be 100 into a minus 4 plus 100 ar plus ar square. That means, in the resulting number, 3-digit number, hundreds place is a minus 4 and tens place is ar and units place is ar square. Okay. So, what are in AP? A minus 4 ar square are in AP. Okay. Let us write it. Therefore, a minus 4 ar square are in AP. Then what is the property of AP? If A, B, C are in AP, 2B is equal to A plus C. So, here 2 into the middle one, 2AR is equal to this plus this. A minus 4 plus AR square. Alright. Now, we have to solve this equation. First, let us write AR square. Next, minus 2AR plus a minus 4 is equal to 0. I am writing it as a quadratic equation. Okay. Now, we can't factorize it. So, what we do? We calculate the values of r by the formula of roots of a quadratic equation. What is the root? What are the roots of a quadratic equation? Minus b plus r minus root of discriminant by 2a. So, I am going to apply that formula. R is equal to minus b means 2a plus r minus root over b square means minus 2a whole square, 4a square minus 4 into a into c, that is 4a into a minus 4. Divided by 2a. Now, I am getting 2a plus r minus, if you multiply 4a square plus 4a, 4 square a you will get, 4a square cancels, you will get root over 16 a square by 2a. Root 16 is, 16a only. Okay. Root 16 is 4, so I will write it as 2a plus r minus 4 root a by 2a. Further, you can write it as 2a by 2a 1 plus this by this is 2 by root a. But here, if you observe what kind of number r should be, let us observe. A is an integer, AR is an integer, positive integer lying between 1 and 9. That means AR by A is what? Integer by integer. AR by A must be integer by integer, that is rational, any rational number. So, since A and AR both are positive integers between 1 and 9, dividing them we will get R. R should be a rational number. Let us write here, since A and AR are positive integers, R should be a rational number. This is one point, and another point is here after subtracting we must get a 3-digit number only. That means a minus 4 should be greater than or equal to 1. Am I right? A minus 4 should be greater than or equal to 1 because a minus 4 is the digit in hundreds place after subtracting 400. So, a minus 4 should be greater than or equal to 1 means it should lie between 1 and 9. In addition to this, I am writing 1 is less than or equal to a minus 4 less than or equal to 9, because a minus 4 is a positive digit. So, adding 4, you will get 5 is less than or equal to a less than or equal to 13, but digit cannot vary up to 13. Maximum value of a digit is 9. So, this side I am writing 9 only. Now, R should be rational. So, A should be a perfect square. A should be a perfect square and A should lie between 5 and 9. Then what is the value of A? You can easily guess. In the interval 5 to 9, what is the perfect square? Only one number, 9. Therefore, since A should be a perfect square, we get A is equal to 9 from this condition. If A is equal to 9, what is R? Sorry, here plus or minus should be there. So, R is equal to 1 plus or minus 2 by 3. Square root of A is 3. If you take minus sign, you will get 1 by 3. If you take plus sign, you will get 5 by 3. If you take R is equal to 1 by 3, what are the numbers? The 3-digit number. First, what is it? A. A means 9. Next number, AR. I am taking R is equal to 1 by 3. Then AR will be 9 into 1 by 3, 3. Next, AR square, 9 into 1 by 3 whole square, that is 1. The 3-digit number is 931, 931. If you take 5 by 3, R is equal to 5 by 3, first digit is 9, second digit is AR. AR means 9 into 5 by 3, you are getting 15, but digit cannot be 15. So, this case is ruled out, is it not? So, we are getting only one answer, that is 931. Let us proceed to the next question. If A, B, C, D are in GP, show that A square plus B square plus C square into B square plus C square plus D square is equal to AB plus BC plus CD whole square. Here there is no calculation involving product of all three numbers, all three or all four. So, no need to take the numbers as A by R cube, A by R, AR cube. You can take in the usual way. What is it? A, AR square, AR cube. So, let the given numbers be A, AR square, AR cube. That means B is AR, C is AR square, D is AR cube. Just substituting in the LHS. First A square is A square only, B square is AR whole square, that is A square R square, plus C square is AR square whole square, that is A square R power 4, into B square is A square R square plus C square A square R power 4 plus D square is A square R power 6 no, D square AR square AR cube. Okay. Now, taking A square common from here, and here A square R square is common. Taking A square common here, A square into 1 plus R square plus R power 4. Here taking A square R square common, a square r square into 1 plus r square plus r power 4. Then this into this can be written as whole square. This into this is a power 4 r square into 1 plus r square plus r power 4 whole square. Now look at the RHS. We have to write it as some perfect square. So how can you write this as whole square? This is a square r whole square. So totally a square r into 1 plus r square plus r power 4 whole square. Now taking a square r inside the bracket, a square r into 1 a square r plus a square r cube, r into r square r cube plus a square r into r power 4 is a square r power 5 whole square. Now a square r is a into ar, that is a into b. So we can write this as ab. A square r cube is ar into ar square, that is bc, b into c, plus bc plus a square r power 5 is c into d, this into this. So plus cd whole square, which is equal to RHS. Alright. Next question. Find the sum 2 plus 22 plus 222 and so on till n terms. As it is not a GP, but we can convert this into a GP and find the sum. And as it is, you cannot write the nth term also. Nth term will be 2, 2, 2, 2 and so on, n times you have to write. So I will use one technique and convert this into a GP. Look at this and look at the method and remember it carefully. First you take this given series 2 plus 22 plus 222 plus and so on. Take 2 common first. 2 into, if you take 2 common, this becomes 1, this becomes 11, this becomes 111. 1 plus 11 plus 111 plus and so on. Still you are not able to write the nth term. Now the actual technique. We have to apply the actual technique now. Divide by 9 and multiply by 9. You will get 2 by 9 into multiplying by 9, you will get 9 plus 99 plus 999 plus and so on. Now we write 9 as 10 minus 1, 99 as 100 minus 1, 999 as 1000 minus 1 and so on. It is equal to 2 by 9 into 10 minus 1. This is 100 minus 1. 100 is nothing but 10 square. So I will write it as 10 square minus 1. Next one will be 1000 minus 1, that is 10 cube minus 1. And so on for n terms. Now you will be able to write the nth term. What is the nth term? By observing the pattern, 10 minus 1, 10 power 1 minus 1, 10 power 2 minus 1, 10 power 3 minus 1, nth term will be 10 power n minus 1. Okay. Now, collecting the first terms of each bracket. We will get 10 plus 10 square plus 10 cube plus and so on till 10 power n. Alright. Now collect the second terms. Second terms are what? Minus 1 plus minus 1 plus minus 1 and so on n times. What is it? Minus 1 into n. That will be minus n. Bracket close. Now this is a GP, geometric progression. You can apply the formula. 2 by 9 into What is this sum? A into r power n minus 1 by r minus 1, because mod r is greater than 1. Common ratio is 10, first term is 10. So, its sum is going to be 10 into A into common ratio 10 power n minus 1 by 10 minus 1, that is 9 minus n. Now you write the final answer. This taking 2 by 9 inside, 20 by 81 into 10 power n minus 1 minus 2n by 9. Alright, this is our answer. Now I am going to give you one more question similar to this, almost similar. Just I will explain few steps and leave it, you can calculate later. This time 0.5 plus 0.55 plus 0.555 and so on. We use the same technique. First we take 5 common, you will get 0.1 plus 0.11 plus 0.111 and so on. Multiply by 9 and divide by 9. 5 by 9 into, you will get 0.9 plus 0.99 plus 0.999 and so on for n terms. Now we write 0.9 is 1 minus 0.1, 1 minus 0.1 plus this is 1 minus 0.01, next is 1 minus 0.001 and so on. Now 0.1 is nothing but 1 by 10, 0.01 is 1 by 10 whole square, 0.001 is 1 by 10 whole cube and so on. Then 5 by 9 into 1 minus 1 by 10 plus 1 minus 1 by 10 square plus 1 minus 1 by 10 cube and so on. Now you can tell the nth term. Nth term is 1 minus 1 by 10 power n. Now you can complete the calculation work, collect the first terms 1 plus 1 plus 1 and so on, that is n. Collecting the second terms and taking minus common, that will be a GP with common ratio 1 by 10. So you complete the calculation. Let us proceed to the next question. 3 distinct numbers are in GP. 3 distinct real numbers are in GP. Their sum is alpha into s and the sum of their squares is s square. Then show that 1 by 3 is less than alpha square less than 1 or 1 is less than alpha square less than 3. Alright. Now as usual we take 3 numbers as A, AR, AR square, because there is no product involved in this question. Let the numbers be A, AR, AR square. Alright. Now the sum of the 3 numbers is alpha s. Sum is equal to, if you take A common and add A into 1 plus R square, it is given as alpha into s. Next, sum of the squares. What is sum of the squares? A square plus A square R square plus A square R power 4. Take A square common and write A square into 1 plus R square plus R power 4 is given as capital S square. This is the given information. Now we have to find the interval of alpha square. How do you get alpha square from these two? Squaring the first equation and dividing the second equation, we are going to get alpha square in the RHS, is it not? So squaring and dividing. Squaring the first only. And dividing by second. Alright. Then this side you will get a square into 1 plus r square whole square by this side dividing by this as it is. A square into 1 plus r square plus r power 4 is equal to alpha square s square, square of this by s square. Alpha square cancels, here a square cancels, then alpha square is equal to 1 plus r square by 1 plus r square plus r power 4. We have to find the interval of alpha square, means we have to find the range of this. R is any real number, but usually as I said earlier, we won't take r is equal to 1 or minus 1. Okay. Excluding that case, if r is equal to 1, what happens? All numbers are equal. Here distinct real numbers he said, so automatically r is equal to 1 is ruled out. Okay. Now, how to find the range of this kind of term? 1 minute, what is here you are having whole square, na? So you will get whole square here. Now, keeping the numerator as it is, you can factorize the denominator. How? You can write 1 plus r power 4 as 1 plus r square whole square minus 2r square. A square plus b square is a plus b whole square minus 2ab, that formula. Plus remaining term r square. Now what is the denominator? One plus r square whole square minus 2r square plus r square is minus r square. Alright. Now denominator can be factorized. A square minus b square is a plus b into a minus b. So we get 1 plus r square whole square upon 1 plus r square plus r a plus b into a minus b. 1 plus r square minus r. What happens now? Common factor is there, that will cancel. 1 plus r square will cancel. So alpha square is 1 plus r square upon, this can be written as 1 minus r plus r square. How to find the range now? This is alpha square, cross multiplying by denominator. If you have attended equations in equations, you might have observed the method of solving, method of finding the interval of alpha square for this kind of question. Cross multiplying, we get alpha square into 1 minus r into alpha square or alpha square into r plus alpha square into r square is equal to 1 plus r square. Now you can write this as a quadratic equation in R. Taking everything into LHS, you will get alpha square minus 1 into r square. Next taking this one this side, minus of alpha square plus 1 into r plus alpha square minus 1 is equal to 0. Now what are you going to do? After getting the quadratic equation, discriminant must be greater than or equal to 0 because r is real. Since r is real, discriminant must be greater than or equal to 0. What is the discriminant? Alpha square plus 1 whole square minus 4 into alpha square minus 1 whole square should be greater than or equal to 0. You can write 4 as 2 square, then you can factorize it as alpha square plus 1 plus 2 into alpha square minus 1. I am applying a square minus b square is equal to a plus b into a minus b into alpha square plus 1 minus of 2 into alpha square minus 1 greater than or equal to 0. And what is this? Simplifying 3 alpha square minus 1 into, simplifying this, you will get 3 minus alpha square is greater than or equal to 0. Now, if you write this as alpha square minus 3, it will be comfortable for us to write the solution. So, I will change this as alpha square minus 3, that means sign will change. So, this greater than becomes less than 3 alpha square minus 1 into alpha square minus 3 less than or equal to 0. Then what is the solution? If x minus alpha into x minus beta is less than 0 or less than or equal to 0, alpha lies between, x lies between alpha and beta. So, here alpha square lies between the roots 1 by 3 and 3. 1 by 3 less than or equal to alpha square less than or equal to 3. But if alpha square is equal to 1 by 3, what happens? If alpha square is equal to 1 by 3 or alpha square is equal to 3, you can observe that discriminant is 0. Then if you check the equation, suppose alpha square is equal to 3, I am substituting, that becomes 2r square minus 4r plus 2 is equal to 0. Then you are getting r is equal to 1, not allowed. So, we have to remove the equality here. In the same way, you can substitute alpha square is equal to 1 by 3 and check. You cannot take equality. And one more thing, here if alpha square is equal to 1, what happens? We have to prove that alpha square lies between 1 by 3 and 1 or 1 and 3, means alpha square cannot be 1. If alpha square is equal to 1, what happens? In this equation, you are getting minus 2r is equal to 0, r is equal to 0. So, r cannot be here, common ratio of a GP cannot be equal to 0 also. Therefore, alpha square is equal to 1 is also not possible. So, alpha square lies between 1 by 3 and 3 and alpha square is not equal to 1. So, it is the solution 1 by 3 to 1 union 1 to 3. Alright. So, with this we have completed today's class, and we are going to discuss harmonic progression or HP in the next class. Then we will solve problems on AP, GP, HP. Okay. Thank you for watching. See you in the next class.